Amazing people. We've got another example here of loans in geometric series. So Sam lends $5,000 on the condition that she is repaid the money plus interest in 10 equal quarterly installments. The first month is to be repaid 3 months from the loan date. If the loan earns interest at a rate of 4% per quarter, what is the amount of each installment? So as we go to answer this, first of all, let's define our monthly installments. And what I want to do is I want to define them as P dollars for each of them. And then the amount owing after n months, I want to define this as A dollars as well. Now, as we start this off, let's look at each month one at a time. So let's look at the first month. So in the first month, what we're going to have is A1, and this is going to be equal to, we can see we've got $5,000 as our principal here, and we're just applying simple compound interest here. And the rate which we have is 4%, so that's going to be times 1.04, and then we just need to minus the repayment at the end of that. That's the first month done. As we move on to the second month now, what we're going to have is A2 is equal to 5,000 times 1.04 minus P. And this is taken from this here because whatever we have at the end of the first month is going to start off our second month. And then as well as this, we need to multiply that by 1.04 and we need to minus P as well. Now I want to expand and simplify and rearrange this a little bit. So first of all, I'm going to have $5,000 times 1.04. In this case, it's going to be squared when I times these two together. Then in addition to that, what I want to do is I want to have minus P. I'm factorizing it out from here and here. And I'm also going to rearrange things here as I do that. So as I factorize that out, I'm going to have a 1. And that comes from here when we factorize out negative P. I just want to reverse the order of these. And then I'm going to have plus 1.04. And that's at the end of the second month. Now let's continue by looking at month 3. So for this one, we're going to have A3 is equal to 5,000 times 1.04 squared minus P bracket 1 plus 1.04 bracket times 1.04 minus P. Now, as we do this here, I've taken this here is from the end of the second month because that's what we had at the end of the month. So it's going to start off the next month. Then I've got the next repayment being processed here. Now, what I want to do is I want to be able to expand these brackets and rearrange this a little bit. So I'm going to have 5,000 times 1.04 cubed now. Then I'm going to have minus P as I factorize minus P out of both of these scenarios here and here. And then as I keep expanding and factorizing, I'm going to have bracket 1, which comes from the last part of it here. Then I'm going to have plus 1.04 plus 1.04 squared. And this is the end of the third month. Now, this is helping to establish the pattern here as we keep going on. So what we're going to find for those 10 months, we're going to have A10 is equal 0 because it's fully repaid at the end of those 10 months. So what we are going to have then is we're going to have 0 is equal to 5,000 times 1.04. It's going to be to the power of 10. Then it's going to be minus P bracket, and we're going to see, this is where we've got our geometric series of 1.04 plus 1.04 squared plus dot, 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 all the way up to 1.04. This is going to be to the power of 9, and we can close the brackets there. So with this here, we have this as our geometric series. And so we can start to change this around and find the sum of it. So remember, S of n is equal to A bracket R to the n minus 1 over R to the R minus 1. So in this case here, this is our formula, which we have to use. And we've got A is equal to 1, R is equal to 1.04. And in this case, n is equal to 10 because there's 10 different terms within this. Now, from here, we're going to have S to 10 is equal to, well, 1 brackets 1.04 minus 1. That should be to the power of 10. And then we've got 1.04 minus 1. If we want to kind of simplify this a little bit, we have 1.04 to the power of 10 minus 1 over 0.04 in this instance. Now, putting this back in and rearranging back up this from up here, we do this in 2 steps. We're going to have, first of all, let's rearrange it first. P is going to be equal to 5,000 times 1.04 to the power of 10 and that's going to be over 1 plus 1.04 plus 1.04 squared plus all the way up to 1.04 to the power of 9. Now we know that that denominator can be replaced. So as we do that now, end up with $5,000 times 1.04. Now it's going to be replaced with this here, of which we need to also flip it because we're dividing it. So since we're dividing by it, that means when we flip it, it changes to a multiplication. So it's going to be 0.04, and that's going to be all over of 1.0410 minus 1. So from this, we can work out our value of P, and that's going to be $616.45. So what we can say here, we can make a statement that Sam receives $616.45 per quarter. So that's going to be the size of each installment.